So, good evening. I'm going to create the midterm examination and analyze the student dataset by applying hierarchical clustering to group student based on their information. So, let's start. Mm, Ayun, going. So, first is import numpy as np. Ayun, pandas as pd. Import mat. So, this is the import libraries. Oh shit, what is happening? Mm-hmm. Okay. So this is the import libraries. NumPy is imported uh, as an NP for numerical operations, although it's not used directly here. Pandas is imported as PD to this as PD to handle data as data frames. Matplotlib that pyplot is imported as PLT to create plots and visualizations. So next is CSV. Student info form. Oh no. Oh no. ED read screen. Mm-hmm. So load the datasets, reads the CVS file named student info for clustering cv.cvs and stores it in the pandas data frame called df. Next is So the se- the select d types function selects only the columns with numerical data types, and the float and int 64 from df, storing them in a new variable x. This can be useful for clustering, as clustering methods typically require numerical input. So sa question no sa notebook outline, sa notebook outline, sa ano sa ito ay kini Ana- analysis questions. What what insight can you gather from each clusters? For example, do students in one cluster tend to have higher GPAs and study more than ours? So, based on what I've observed, uh, insight can you gather from each cluster? So, lahi sila og kuano GPA each students murag sige grade mo GPA ba? Sa GPA. Kita na video. Ah, performance. Lagi. Lahi sila GPA no. Silang mga performance kay lahi man sad gyud og kuan. Lahi og performance each students. So sa akong uban nga na observe, mm, niabot sila og 1,000 ka buok rows or 1,000 ka buok students, pero dili sila pareha tanan. Di sila pareha og GPA. Bisan pa og kuan, dag kanang 1,000 sila ka buok. Mao akong na-observe. Unsa tiyang question? Gather for to have higher GPAs and study more hours. Study more hours. Mm. Bisan pag lain sila GPA, ah ang ilang study hours no. Bisan pag gamay ni siya og GPA, pero mas dako pagyapon og study per hours ang kani siya. Example, mangita ta example. mm, Lagi mo na to. Sa mukha. Muna ako na observe. Next. Uh, Next is kuan na ta. Mag-generate a dendrogram. Dendrogram. So import import unsa ni SPP SIP SIP that cluster hierarchy as SCH, which will be used for hierarchical clustering, and dendrogram generation. So mo na siya ang kan sa dendrogram no para ma-import. Then the equals SCH. Euclidean. Lah, ano naman yan? Linkage. Diyan maningi. Euclidean. Nalday. Lah. Ay, no labels. Hi, samo ka. So, no, naka-create ta og naka-generate ta og dendrogram. So, atong i-explain. SCH linkage. Well, SCH linkage. DF method. Kani siya nga kwan. Kani siya nga column is hierarchical. I creates a linkage matrix for hierarchical clustering using the wards method. Wards method minimizes the variance within each cluster using Euclidean distance by default. No need to specify the metric Euclidean. Og sa SCH og kaning sa HCH dendrogram plots the hierarchical clustering as a dendrogram which shows the structure of how samples can be grouped based on linkage distance. The no labels equals true parameter removes sample labels from the x-axis. So I'm going to the TL. O lagi. Na 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 na. Sumpay man siya ba? Or lahi ni siya? Ay, ang lagi. Sumpay lagi. Student. So customize and display the dendrogram. So I customize the display of the dendrogram, adds, tit- adds titles and labels to the dendrogram plots. PLT title sets the title as this dendrogram, and PLTX label and PLTY label sets labels for the X axis and Y axis. PLT show displays the dendrogram. So yeah, that's it. Next is ito. Sumpay mo nila ba? Ani?
Ano, sa pan? Nasumpay na silang doon.
It's equal 400. So langan ni.
Ano ba? Saan na lang yan?
Ay, from ni. Nara day. Okay. Uh, import ag I import agglomerative clustering. Se. So, I apply the agglomerative clustering sa kaning kuan. So, imp wait, no. So, import agglomerative clustering from cluster, which will be used to apply clustering based on the dendrogram analysis. So, this each so initializing agglomerative clustering creates an instance for agglomerative clustering named HC, where in n how many in the beginning in clusters in clusters equals none. The number of clusters is not set beforehand, allowing the clustering to be based on distance threshold threshold. Distance threshold equals 400. 400 specifies the maximum linkage distance at which clusters should stop merging. This threshold determines the number of clusters in the datasets. So, ano pa gyapon ni? Mm.
Sa ubos na, sa ubos. Sumpay lang na. Sa ubos.
Ano?
Dili, sa ubos dili. Wala na, wala na tungkol.
Mm-mm.
Wala na siya.
So each C that fit DF fits the clustering models to the data DF. This step assigns each sample to a cluster based on the chosen distance threshold. So this is the allogluterative clustering distance.
Ha? Kasi,
Wala pa ang result by sa kuan. So this is the result no sa kuan. 14. So that's all and experiment. Wala ko ka-explore ba wa kay ko na kuan. That's it. Bye bye.